Okay, today we are going to talk about writing equations of parallel and perpendicular lines. So, before we do that, there's a couple basics that we need to understand. Parallel, anytime you see that symbol like that, it looks like an 11, but it's a little bit skinnier. It's just closer, maybe a little bit taller than the number one. That's a sign for parallel. If you see the upside down T, that's a sign for perpendicular. All right, now what does that mean? Parallel. So parallel means slopes are the same. They're going to be the exact same number. Okay, the exact same measure. It means two lines that they're going to never touch. They go on forever, both directions. They never cross. However, perpendicular lines, they intersect at 90-degree angles. So two lines will come together. Example would be this. I mean, your XY axis. Your XY axis is perpendicular. The X axis is perpendicular to the Y axis, and where they come together, they all form right angles all the way around. Okay. Now, slopes. This is definitely important. Slopes of perpendicular lines are what we call negative reciprocals. Okay, they're negative reciprocals. And then I would also say put equals -1. And we're going to show you what we mean about that here in a second. Okay, so number one, there's a line that goes through this point, -3, 1, and it's parallel to this line, y equals -2/3 x minus 2. So I'm going to use my point slope form, but I need to identify, I need a point, which I do have a point, x sub 1, y sub 1. I need a slope. And it's already written in slope intercept form, so this is my m. So I have everything I need. I know if the line is parallel to this line, it's got to be the same slope. So I'm going to set it up. Y minus 1 equals -2/3 times the quantity x minus -3. Make that a big positive then, and let's distribute. So I bring down y minus 1 equals, I get -2/3 x, and when I multiply this, that's going to simplify to -2. Okay, I'm going to add 1 to both sides, cancels, so we get y equals -2/3 x minus 1. So this is the equation of a line that's parallel to this one, and it goes through this point. All right, let's try that one more time. So come over here. The key is to identify, is it parallel or perpendicular that you're talking about? Again, this one's parallel. So start off, label the points, x sub 1, y sub 1. Identify your slope. It's in slope intercept form, so that's good. And then set it up. So y minus -4 equals -7/3 for my m times the quantity x minus x sub 1, which is 3. Okay, so I want to make this a big positive. I'm going to go ahead and distribute this. Bring down y plus 4 equals, we get -7/3 x. When I multiply these together, that's going to be a positive 7. Okay, so I'm going to subtract 4 to both sides. That cancels. So I get y is equal to -7/3 x plus 3. So again, this is the line that's parallel to this one. They got the same slopes, but it's going to go through this point. Okay, number 3. So number 3 is the first time that we see one that says perp, which stands for perpendicular. Okay, we talked about above there where slopes of perpendicular lines are negative reciprocals. So what I want to do first is I want to pull that slope out, -5/2. Okay, and when I say it's a negative reciprocal, I mean it's the opposite reciprocal. So the reciprocal of negative 5 halves would be 2/5, but because it's the opposite, this one has to be a positive. Okay, if I were to take both of these slopes, the original and the one that I think is the one that's perpendicular to it, if I multiply them together, so we get negative 10 up top, 10 on the bottom, it's going to reduce down to negative 1. Okay, that's always going to be the case. That's a good self-check piece. So the two slopes, perpendicular slopes, if you multiply them together, they're always going to equal negative 1. Okay, so we determined this is the slope we need to use, 2/5. Okay, so I'm going to come over here and now rewrite it. So y minus 0, using this point right here, equals, now my slope's going to be at 2/5 times the quantity x minus 5. Okay, let's distribute. That y minus 0, well, that 0 just falls off. And we now have 2/5 x. And when I multiply that in, that's just going to be a negative 2. So that's simplified right there. And so this line, if I was to graph it, it would be perpendicular to this one. And it would go through this point. Okay, let's go over to number 4. So let's take a look at this slope. This slope's a negative 4. So I need a negative reciprocal of that. And again, it's just the opposite reciprocal. So technically that's negative 4 over 1. So that would convert to a 1 over a positive 4. And if I was to multiply those together, that would reduce down to negative 1. So 1/4 is the slope that I need to use. Okay, set up point slope form. Y minus 1 equals 1/4 times the quantity x minus 1. Okay, distribute. So y minus 1 equals 1/4 x minus 1/4. And then if I add 1 to both sides, that would cancel. You get y is equal to 1/4 x plus 3/4. So again, this line is going to be perpendicular to this one, and it's going to go through this point. All right, you guys go ahead now and do number 5. Number 6. Number 7, be careful, because look at this equation. This is an x equals 0. So think about this one. Think about how this one was graphed, and then you're going to need a line that's going to be parallel to that one, but it's got to go through these points here. So you don't necessarily need to use the point slope formula on this one because this is a weird line. So just think how it's graphed and how it's going to go through these points and what that next line would look like if it's parallel to that. Okay, number 8. Number 9. 10. 11. 12. 13. And again, look at number 14. We have another x equals 0, but this time it's perpendicular to that one. So again, you don't need to use point slope form, but just think how this is graphed and what line would be perpendicular to that one that would run through this point here. Okay, that's it.